Welcome to this session of 10.5. This is polar area. A couple of things real quickly. This is just an experiment, and through the circumstances of today, obviously we're going to try this. Let's call it flipping the classroom. So I'll give you the lesson here, hopefully, and then we can answer questions later. Okay. A couple of things to remember real quickly. We had the slope formula coming back from the previous lesson. You could always derive it back from the equation in regards to slope. If you remember dy over d theta, and x standing for r cosine theta and r sine theta, we could use the product rule to apply the dy over dx. And if you remember from the last test and the last unit, the horizontal tangent line is where you're focused on your y equal out to 0. In this case, so your derivative of y equal to the derivative of theta equals to 0. And your vertical is d of x over d theta, also equal out to 0. Just real quickly, before we start with vertical tangents, that we write the question with the parametric form if possible. In this case right here, we're not dealing with time, we're dealing with theta. Finding the slope, making it equal to 0, and then rewriting the equation if it's telling us to rewrite it. In this unit, actually, we're probably not going to end up rewriting it. What we're going to try to do is just trying to figure out the slope of the tangent line and actually correspond to what coordinates and what points there are to be. So example number one states that find the horizontal vertical tangent line of r sine theta, where 0 is less than or equal to theta is less than or equal to pi. We're going to ask to find the horizontal and the vertical tangent. Horizontal tangent, as you guys remember, has a slope of dy equals out to 0. It's a 0 slope, horizontal, left to right. So if we're looking for our equation, it's our equation in terms of y. So as we go through this, we understand that the horizontal tangent of this equation is applying to the original y equation. And from doing so, before we figure out the horizontal vertical tangent line, actually we need to figure out what x and y could be. We plug in r, and r stands for r sine theta. So we get r sine theta listed. R sine theta as we apply it into r. Going towards the sine right there. So r cosine theta, r standing for r sine theta. And the same thing r applies to sine. Sine theta becomes sine squared theta. And as we continue with this here, first off with the horizontal tangent is when y is 0, dy over dx. The y is equal out to sine squared theta. We take the derivative because we're dealing with tangent. The derivative of sine squared theta is also staying, the fact is 2 sine theta cosine theta. Now hopefully you remember how to find the derivative of this here. It's also stating sine squared theta. So from there we can apply the chain rule, put the 2 in front. Sine theta, the derivative of sine is cosine theta, divided by d of x. D of x, on this case right here, we have 2 components. We've got to use the product rule. Fg prime plus gf prime. So sine, the derivative of cosine is negative sine plus cosine theta times also another cosine theta there. And of course dy by dx, if we simplify that there, we have sine squared theta times sine squared theta is negative sine squared theta, and then cosine theta. Cosine squared theta is applying to the other side. And the horizontal tangent from here, we're applying, as we apply to this equation here, horizontal tangent is your y. Your y is sine squared theta. So your dy by dx is, your dy rather, is 2 sine theta cosine theta. And as we get from that equation there, we combine the fact that from that equation, what we understand is, if you remember your trig identities back in pre-cal, 2 sine theta cosine theta equals out to one of the inequalities, or actually identities of sine 2 theta. From there, go ahead and make it equal to 0 and find out where it belongs. And as we figure this out as where it belongs, 2 theta equals out to 0 and 2 theta equals out to pi. So we said 2 theta equals out to 0. Okay, get my pen to work again. 2 theta equals out to 0 and 2 theta equals out to pi. You're asking where I got all this from because you need to figure out what the unit circle equals out to where 0 is at. 2 theta equals out to 0, and then in this case right here at pi you have -1 comma 0, and that's also 0 there. But we've got to establish where theta is by itself. Divide by 2 on both sides. So in this case right here, we know theta equals out to 0, theta equals out to pi over 2. Now when we plug it back in, where sine of 0 and sine of pi over 2, we get our coordinates as being 0, 0, and 1, comma 1 pi over 2. It's r comma theta. If you remember in terms of your equation of the vector, or in this case here, the equation of a polar, your radius comes first, your angle comes in second, your radian. And how I got pi over 2 is you plug in sine 2 times pi over 2, the 2's cancel out, sine of pi is at 1. To get your vertical tangent, what you're going to do is that in this case right here, it's where your slope is going to be undefined, or no slope situation. And in this case right here, your x is going to be x sine theta cosine theta, okay? And in this case right here, if you take the derivative of that, basically, as we tried to derive it last time as we figured out the slope, cosine squared theta minus sine squared theta equals out to 0. You factor the problem out. It's just like a regular factoring equation. You've got cosine theta plus sine theta, cosine theta minus cosine theta. Cosine theta minus sine theta, apologize for that, equals out to 0. Make those equations equal out to 0. So you end up getting cosine theta equals out to negative sine theta, and cosine theta equals out to sine theta. So in this case right here, think where the unit circle is and where these two coordinates will equal out to each other, or in this case here, where the cosine is going to be positive and sine is negative. Well, the first step, we know that cosine and sine are going to be both positive at pi over 4. So we know for the fact that it's going to be, if you pi plug to them, the r is going to be root 2 over 2, the radius, of course, the hypotenuse of that equation there. But where is cosine and negative sine going to equate to each other? Well, we're going to have to focus on the second quadrant, 3 pi over 4. And, of course, we know for the fact there, it's going to be still root 2 over 2. Okay, so as we plug that equation in there, we know that root 2 over 2 will give us those answers over the 3 pi over 4 and pi over 4. Okay, so as we decide at the end with this example here, we get those 2 points. If you were graphing this out, and please pardon my artistic ability here as I try this out here, I was trying to new things out here. So we know for a fact that pi over 2 is at 1. So here's 1. This is 1 comma pi over 2. And at root 2 over 2, because that's your r, that's your x-axis right here, we know this is going to be 1. So root 2 over 2 is halfway. Pi over 4 is going to be here. And this is -1 there. And then you can draw a much better circle than I can. Okay. Example number 2. Find the horizontal vertical tangent of r equals out to 1 minus sine theta, where the restrictions are 0 to less than or equal to theta is less than or equal to 2 pi. So now we're going from 0 to 2 pi here. Same situation applies. X equals to r cosine theta, y equals to r sine theta. We know r equals to 1 minus sine theta, so you just plug it in. Okay? And if you plug it in from the d, and we're finding the horizontal, we're just finding the horizontal tangent. We're not finding the vertical tangent. I apologize for that. If we're just finding the horizontal tangent, it's your horizontal is on the bottom. So r sine theta is your derivative. So from there, we get the equation r cosine theta equals r prime sine theta as we derive it back from dy by dx. In this case right here, we know r is 1 minus sine theta. We plug that in with cosine theta plus the derivative of 1 minus sine theta is negative. It's still going to be take the derivative of sine as cosine, bring the negative down. Sine theta, cosine theta times sine theta. From there, what we're going to do after we get the equation is let's go ahead and distribute the problem out with the cosine on both sides and the cosine and the sine. As we distribute this one here, we got the cosine theta minus sine theta plus cosine theta sine theta. As you guys recognize through this right here, make sure you distribute properly. The one with the cosine, the one with the sine. And order doesn't matter. I don't know why I did that, but we went ahead and do that. And you realize the fact that you have 2 cosine theta sine thetas plus cosine theta equals out to 0. Now here's the thing you have to remember back to pre-cal, is that where are you getting from the 2 cosine theta sine theta coming from? If you remember one of your trig functions, it actually distributes down to 1 minus 2 sine theta. It's one of your 3 identities going back to pre-cal. Hopefully you remember those, and if you don't, hopefully you know now. From that part right there, you make it equal to 0. Cosine theta equals out to 0. 1 minus 2 sine theta equals out to 0. And you're going to find out, well, where does the unit circle equal out to cosine theta equals out to 0 at? Well, we know it equals out to pi over 2 and 3 pi over 2. And 1 minus 2 sine theta equals out to 0. And with that process right there, use your algebra. Subtract the 1 to the other side. And then you got negative 1 divided by negative 2. 2 negatives make a positive. You got sine theta equals to 1/2. And we know at 1/2 theta equals up to pi over 6. And at 5 pi over 6 above the y-axis. And as we established from that part there, the next step is, after we establish all this, now we had to figure out what's your r in this one here. Even though the radius is equal to that equation right there, but we know what the theta is, now let's plug it in. So r equals up to 1 sine pi over 6. Pi over 6 is going to be 1/2. 1 minus 1/2 is going to be 1/2. Do the same thing with the others. Okay. So we got our 4 established points there. We're not fully done after we plug it into all those 4 points in there. And by those other 4 points right there, the last thing we need to do is figure out we're going to have to graph this out. So we have our 4 points. So what we have to understand from here is that at 1/2 pi over 6, okay, so here is pi over 6 approximately here. We're taking a guesstimation. Obviously, this is 1/2 pi over 6. This is 1/2 5 pi over 6 going to the second quadrant. Remember, this is quadrant 1, 2, 3, and 4. Okay. And we got at 2, 3 over 2. Sorry, my lines are not lined up, but we're going to assume this is 2 as we graph this out. I think I made my points as being every pi over 4 listed over there. But our last point is going to establish at 0 pi over 2. The rule with the derivative when you go here is if it has a sharp turn, you cannot take the point from there or the derivative. So you can't establish a tangent line there. So if there's no derivative based on a sharp turn back from first semester, you won't be able to solve that there. So that's why the 0 comma pi over 2 is non-existent as a considered tangent line. And when we say tangent line, it's basically saying at this point here, we can make a line that goes left to right. Okay? Any questions? If you got questions, feel free to talk to me. And example number 3 is the next one actually is going to be your turn. This is an opportunity for you to try one on your own. The question reads, find the vertical tangent lines of r equals up to 1 minus sine theta, where 0 is less than or equal to theta is less than or equal to 2 pi. Remember, this is asking for the vertical tangent line, so feel free to go back to your previous example, look at that work, so if you can understand this one here, pause the video, try it out. When you're ready, press the play button. Welcome back. Hopefully you started from this part here. Pardon my fantastic handwriting there, but obviously we have from the derivative equation d of x equals to negative r sine theta plus r prime cosine theta. As we go and continue with the equation from there, we know cosine squared theta minus sine squared theta plus sine squared theta equals out to 0. Now, what I want you to remember is that you go back to your trig identity, and what does cosine squared theta equal out to? Well, first off, we have a negative, and because of a negative outside, we take a -1, and it's going to equal out to 1 minus sine squared theta. Hopefully you remember that equation from there, going back to your trig function, minus sine theta plus sine squared theta equals out to 0. Go ahead and clean this up. And as we clean this up, we can distribute the -1 to the 1 and the sine squared theta. So we end up having a positive sine squared theta plus a sine squared theta equals out to 2 sine squared theta minus sine theta, negative minus 1 is going to be -1 equals out to 0 as we combine like terms. From there, we go ahead and factor it out. Just pretend this is 2x squared minus x minus 1. And the two numbers are going to fit in. It's going to be 2x minus 2x plus 1 and x minus 1. So instead of x, you just plug in sine. So 2 sine theta plus 1 sine theta minus 1 equals out to 0. So sine theta equals out to, let's see, say sine theta equals out to 1. And you get 2 sine theta plus 1 equals out to 0. Subtract 1 on both sides. 2 sine theta equals out to -1 divided by 2. So sine theta equals out to -1/2. You can take the inverse if you want, but we know for a fact that sine theta equals out to -1/2. The answers are 7 pi over 6 and 11 pi over 6. And sine theta equals out to, sine theta equals out to 1. Where in the unit circle is going to equal out to 1. It's going to be pi over 6. Pi over 2. Why am I saying pi over 6? I can't read my own handwriting. I wrote it right there. Pi over 2. Okay. Last thing is that we need to plug it into the equation. And if we plug into the equation is r equals out to 1 minus sine theta. And it's r equals 1 minus sine theta. You get 1 minus sine of pi over 2, which equals out to 0 comma pi over 2. Remember, you're going from r comma theta. We got 1 minus sine 7 pi over 6 equals up to 1 minus -1/2. Well, that equals up to 3 over 2. So our second coordinate is going to be 3 over 2 comma 7 pi over 6. And last but not least, 1 minus sine 11 pi over 6. So that's 3 over 2 and 11 pi over 6. And that also equals out to 3/2. So, when you plug it in, we get 3/2. But why does this 0 and pi over 2 not work out? It's because if you remember going back to the same equation, we have that sharp turn. And with that sharp turn, that can't be a vertical tangent line as well. Actually, we'll be able to solve that using L'Hopital's rule, but that'll be a little bit later. Okay? So, review from geometry. Do you remember this equation here? And that's written a little differently. Most geometry as a geometry teacher, we teach this as being a equals pi r squared times m over 360. But of course, we know in pre-cal we substitute that as being over 2 pi, right? So in this case right here, the d theta is just going to represent as the radius. And in this case right here, as we simplify this equation from there, if we were thinking about the equations, the r's just reduced up by 1, so it's pi r theta, if you remember that equation from there. Now, from this equation from the sector area, basically it's saying if you have this curve in between, we can find the sector area based on this equation. If you take the upper bound and lower bound and take the integral, because we're taking the sector area, we can go ahead and find the polar area in between. And of course, we're just dealing with polar now. The equation of this here, and you're going to have to know this, area equals 1/2, the alpha is on the bottom, the beta is on top, r squared d theta. Okay, so in respects to theta. So hopefully you've written this down and got the equation ready as we go with the example number 3. Example number 3 states, sketch the graph of r equals out to 2 plus 2 sine theta. Find the area bounded by the graph. So let's graph it first. We're going to find the area second. So usually with most people, I tell most people to go ahead and graph this out first. Okay, so you can understand what the graph looks like, and identify what type of graph it is, and establish the area from there. First things first, when we sketch the graph from there, make yourself a table. I chose the easiest points as possible. Do not make your life very difficult. Use 1/2, use 0 points if you needed to. In this case right here, if you know sine of 0 is going to be 0. 0 times 2 is 0. 0 plus 2 from r will equal out to 2. So from this table right here, we know this is going to equal out to 2. Pi over 2. Pi over 2 is going to be 1. 1 times 2 is 2. 2 and 2 is 4. And just continuing the process there. 3 pi over 2 is going to equal out to negative 1/2, which is negative 2. 2 plus negative 2 will equal out to 0. When you graph this out, make sure you start at 0 here. That's your 0, 0. Your radius is going to be your x-axis there, so that's 2. At pi over 2, it's halfway in between. We go up 4 spots. And at pi, we go back to 2. And at 3 pi over 2, we're at 0. Here's the thing. Go back to pre-cal. The rule states if these two are the same, first off, it's going to be a centroid. Okay? Because they have matching numbers. That's the rule there. So if you remember a centroid, it's going to have a little curve in here. So you start at 0, 0, and you're going to go from this point here, from 0 to 0. Oh, God. Okay, so we go from that graph there. And from there, it's going to go from here, from pi over 2 to pi. Pi jumps to 3 pi over 2. And then 3 pi over 2 runs down to, and the cycle will go through there. This is what the graph looks like. And essentially, we're trying to find the area in between. An example could be like a windshield wiper. You go from one end to the other end, back and forth. And you have this little area in between that goes from one area to the other area. So you can think of it as a real life example. So that's what the graph somewhat looks like. It's a centroid, okay, as we did from our last example from there. And we're going to find the area. The area equation, as we go with the second step on this one here, as that we go with area equals to 1/2 the alpha and the betas. The alpha's on the bottom, beta's on top, r squared d theta. R standing for the equation, which the radius is 2 plus 2 sine theta squared. We know our lower bound is 0, the upper bound is 2, because we've gone to 2 pi. We can go back to 2 pi and get our equation. Okay, so we don't have any restrictions from there. D theta, go ahead and factor the inside out, go ahead and multiply it twice. 4 plus 8 sine theta plus 4 sine squared theta equals out to 0. Not equals out to, you got the 1/2 on the outside. D theta, rather. Be careful with this question here. The sine squared theta. Go back to your rules in terms of pre-cal. And if you go back to your rules on pre-cal, you know this is going to be one of the specialized angles, okay? And it's what we call the half angle theorem, okay? Because on this case right here, we have a squared. So if we go to the half angle, we're going to substitute as 1 minus cosine 2 theta over 2. So from that equation right there, go and simplify the equation. 2 goes to 4 2 times. As we write the equation again, go ahead and simplify this. 2 goes to 4 2 times, like we said before, and then go ahead and distribute. So that's 1, 2, 2 times 1 is 2, 2 times cosine 2 squared, 2 theta. From there, simplify the equation. You got 6 plus 8 sine theta minus 2 cosine 2 theta. The last thing is to go ahead and try to take the integral. Remember, you're going up. So you go 6 theta minus 8 cosine theta. The integral of sine is negative cosine theta, minus 2 sine 2 theta. Remember the fact that the cosine, the derivative of cosine is going to be sine, from 0 to 2 pi. From there, as we established, from here that we understand, from there we got to take, as we take the integral, let's go ahead and plug it in. 6 times 2 pi is 12 pi. Cosine 2 pi is 1. 1 times 8 is negative 8. We take the 1/2 still outside. 2 pi times 2 is 4 pi. 4 pi is also known as 2 pi. 2 times 0 is going to be 0. On the other side, you got 8 cosine 0. 8 cosine 0 is going to equal out to 1. 1 times 8 is negative. You got the negative on the outside. From there, 2 negatives make a positive. So the 8 and the negative 8 cancels each other out. Half of 12 pi is 6 pi units squared. Please don't forget to label. Example number 4, let's get the nitty-gritty on this one here. It gets a little bit more challenging. Sketch the graph of 2 sine 3 theta and find the area bounded by one petal. Now, it doesn't matter which petal you choose, but remember, make sure to keep yourself easy and simple for you to understand. Now, from there, we need to figure out, well, what are our boundaries are located. So first things first is that we know this is the equation of radius. So let's go ahead and try to find out the area. So in order to do so, put the 2 sine theta, 3 theta equals that to 0, divide by 2, sine 3 theta equals that to 0. Okay, where in the unit circle does 0 exist as sine? So we know it's going to exist at 0, pi, 2 pi, so on and so forth. But the equation is sine of 3 theta. So 3 theta. So from there, we divide both sides by 3. Okay. So on and so forth. So you get your answer. But here's the thing. We only care for about one petal. So we'll have 0 to pi over 3 as our boundaries. Okay. Now those are just our boundaries. It does not mean what the graph looks like there. So if we're going to sketch the graph, here's the thing. We've got, if you remember back to geometry, this is 360 degrees. Now, as we go for 360 degrees, and we know for the fact that this is going to involve one type of petal here. We're going to do with in terms of petals here, we're going to find the area of one petal, but we know for the fact that because this number is odd, we're going to have the same amount of petals in terms of distributed properly. So we're going to have 3 different petals that are evenly spaced. Now the question is, how are we going to find something that's evenly spaced? Okay, so we got 300, we know it's going to take our angle, which is 360 or 2 pi, divided by the amount of petals we have, which is 120 degrees. So for each angle, we're going to move to 120 degrees. Now, as we figure, that's with the spacing of that side. But we need to figure out where the first petal stands at. The first petal is going to start at, because it's from 0 to 90 degrees, we divide on 3 sides. So we're actually going to start, as we figure this out, is at pi over 6. Now, how do we get all that? So you take, because we're doing the first angle, divided by 3, because it's pi over, because of it's a third of that, so it's going to be 30 degrees, or pi over 6. And we know that's going to be our strong point there. So if we were graphing this out, and man, I'm going to have fun with this one here. I picked this one to try out, this one here, right? So we're going to have 3 different petals, evenly spaced by 120 degrees. And we know that this spot here is pi over 6, but this whole area here is from 0 to pi over 3 as we go from pi over 6 to pi over 3. Hopefully you can understand that, okay? And we are going to try to find the area of this region here. Pardon my beautifulness of here. And we know for the fact that this is supposed to be at 2. Because that's our diameter. Well, our radius in this case right here would be 2. This length right here would be 2. Okay? So from there, it's asking for finding the area. In order for us to find the area here, it's going to get a little ugly on this one here. And I would think maybe even this one here. I mean, if you can't do it without a calculator, which you shouldn't be able to do calculator, it's going to get a little ugly, but it's not going to be too bad. Okay? So hopefully everybody understands what the graph looks like. 3 petals from here. So from here, that we're going to go ahead and get the equation, area equals up to 1/2. The lower bound is 0. The upper bound we discussed was pi over 3. 2 sine 3 theta squared d theta. From there, we can go ahead and simplify this by squaring both sides. Area equals up to 1/2, 0 pi over 3. So it equals out to 4 sine squared 3 theta d theta, which is perfectly fine living from there. Now, you can go ahead and distribute the 4 if you, or the 1/2 if you want, or you can leave it alone. It doesn't really matter. So if you leave it from there, we got area equals up to 1/2 0 pi over 3. If you remember your trig functions on this one right here, it's sine squared 3 theta. It's going to be one of your half angles. 1 minus cosine, you double this, which is 6 theta, because the original is 1 minus cosine 2 theta. 2 times 3 is 6. Over, leave the bottom alone, which is 2, d theta. As you simplify this out here, once you get this part here, 2 goes to 4 2 times. So you can simplify that. Okay. From there, the half and the 2 also cancels out. So now you're left over with area equals to 1/2 with the lower bound 0, pi over 3, 1 minus cosine 6 theta, d theta. Now, from there, after you establish the integral, let's go ahead and just apply it in. You know from it's going to be area equals out to, now, the integral of 1 is going to be whatever that turns in terms, this is in terms of theta, so we're going to keep it as theta, minus, this is cosine 6 theta. You got to use the chain rule here, the derivative of 6 theta. You got to put it as a, in this case right here, it's 1 over 6 sine, leave the 6 theta alone. With the lower bound is 0. The upper bound is still pi over 3. Okay. And you could use this even with u substitution. Essentially, it is u substitution. U equals to 6 theta. du is 1 over 6 du. D theta, rather. Okay, so when you get from that part there, apply it in. So pi over 3 minus 1 over 6 sine 6 times pi over 3 minus, well, it looks like 0 times sine of 0 will be 0, so it's going to be 0 minus 0. You get this up here. You should get pi over 3 units squared. Okay. We'll finish this lesson on Friday. I'm giving you the worksheet. Try to finish it up in class. Thank you for your time.